Welcome to this video on the topic of Year 8 Mathematics, Algebraic Multiplication. In this lesson, you'll learn how to write algebraic expressions containing multiplication in the simplest way possible. Algebraic products are composed of coefficients, variables, and exponents. The coefficient is the number in front of the variable. The variable is the letter. The exponent is the item above the variable. Consider we have 3x squared times 5x to the power of 4y. This is an algebraic expression containing products. We know this because there's a multiplication symbol here. To the left and the right of your multiplication symbol, you find your products. In this instance, we have 3x squared, and we have, to the right, 5x to the 4y. We call these products. Now remember, products are composed of coefficients, variables, and exponents. The coefficient is the number in front of the letters. So in this instance, we have a coefficient of 5 over here, and then we have a coefficient of 3 over here. Moving along, we have variables. A variable is a letter. Notice we have one here, here, and here. This expression has 3 variables. However, there are only 2 unique variables, x's and y's. Finally, we have exponents. The exponent is the item above the variable. For this instance, we have an exponent here and we have one here. The exponent represents the number of a variable there is, and they're all multiplied together. So in this instance, we have 4 x's because our exponent is 4. And all of those x's are multiplied together, so it's x times x times x times x. On the left, where we have x to the power of 2, also called x squared, we have 2 x's, and those x's are multiplied together as well. Finally, notice that the y does not have an exponent. This implies that the y has an exponent of 1. When we have exponents of 1, there's no need to write it. Now, in addition to calling these exponents, we also sometimes call them powers and indices. You can call them whatever you want, as shown up here, but for this video series I'm going to call them exponents. Okay, let's have a look at some examples. Example 1. Simplify the following algebraic expressions. We have 11b to the power of 4 multiplied by negative 3y to the power of 3. Now, we use the word simplify here, but we haven't spoken about what does that even mean. When we say simplify, what we're actually asking for is we're asking for an expression to be written such a way that there is a singular coefficient and all the variables are in alphabetical order. Now, the way in which we can do this to this expression over here is firstly, we need to identify all of our coefficients. On the first product, we have a coefficient of 11, and on the second product, we have a coefficient of 3. So what I'm going to do is I'm going to write those coefficients on the far left. Next, I'm going to identify my variables and write them on the right. So I have b's and I have y's. I had a total of 4 b's and I had a total of 3 y's. Next, I'm going to multiply the coefficients together. I know that 11 times 3 is 33, and I know that anything multiplied by a singular negative is going to be negative itself. My variables were b and they were y, and there were 4 b's and 3 y's. So therefore, the simplified form of 11b to the 4 times minus 3y to the cube is simply negative 33b to the 4y cubed. Singular coefficient, variables in alphabetical order with their exponents. Alright, next example. We have minus 2u cubed times 3uv squared. We want to simplify this statement over here. Using the method before, we identify our coefficients. Those were minus 2 and 3. Next, we list our variables. We had u cubed, we had u, and we had v squared. Multiplying the coefficients, 2 3s are 6. It's negative because there was a singular negative. And then our variables were u and v. Now, have a look. From the second line to the third line, I've moved from having all of the variables shown to just having 2 of them. what we want to do is we want to simplify the variables by putting the exponents together. Now up here, u to the power of 3 means that we have 3 u's and they're all multiplied together. Over here we have u and there's no exponent, so that means 1. So in total we have 4 u's. So what we can do is we can simplify the second line to the third by putting all of the exponents on the u's together. For the v's, it's just v squared. So therefore we discover that the simplified version of minus 2u cubed times 3uv squared is negative 6 u to the 4 v squared. Alright, let's look at some trickier examples. Simplify. Simplify the following algebraic products. 7 in brackets 2x squared y. Notice that we don't have a multiplication symbol here anymore. However, this is a bit deceptive. The brackets over here are going to operate like they're a multiplication symbol. We can rewrite this expression to be 7 multiplied by 2x squared y. And thus, we have something that's familiar that we can work with. Simplifying this out, I get the coefficients 7 and 2, and I multiply those together. I get 14. Next, my variables were x and y, and there was a 2 on the x. So the simplified version of this bracketed expression was 14x squared y. Okay, let's wash and repeat. 8u squared v in brackets minus 3uv cubed. What we want to do is we want to write this in its simplest form possible. Now we could do the intermediate step of changing the brackets to a multiplication, but it's practical to work natively with the brackets over here. So simplifying this out, I'm going to identify my coefficients on all my products. I have an 8 and I have a minus 3. So I go 8 minus 3. Next I list my variables in alphabetical order. I have u squared, v cubed. Alright, let's simplify it finally. 8 3's are 24. One of them's negative, so the result's negative. I have u's and I have v's. I have a total of 1, 2, 3 u's. I have a total of 1, 2, 3, 4 v's. Therefore, the simplification here is minus 24 u cubed v to the power of 4. So the takeaway here is when we're dealing with brackets, we can just treat the brackets like their multiplication. Alright, next level of complexity. We have something that looks kinda scary. We have 3x y cubed in brackets minus 4y squared, and in another set of brackets we have 2x squared y. What we're going to do is we're going to simplify this using the methods we've learned before. Remember, brackets mean multiplication. To do this multiplication, we have to identify all of our coefficients. The coefficients here are 3, minus 4, 2. So I'm going to bring those all to the far left and multiply those together. Now, since I'm getting used to brackets, I'm not going to write these with the multiplication symbol anymore. I'm going to start using the bracket. So I have 3, minus 4, and 2. Next, I'm going to list my variables in alphabetical order. I have an x and I have an x squared. I have y cubed, I had a y squared, and I had a y. Alright, finishing this off. 3 by 4 is 12. It was negative, so it's negative 12. 12 2's are 24. One of them was negative, so it's negative 24. Moving along, I have x's, I have y's. I have a total of 1, 2, 3 x's. I have a total of 3, 4, 5, 6 y's. So the simplification of that fairly yucky looking expression over here, simply negative 24 x cubed y to the power of 6. Alright, let's wash and repeat. We have minus 2y cubed in brackets minus 5y cubed z, and then in a final bracket 6y cubed z. Let's simplify this using the same process as shown to the left. Identify your coefficients. We have minus 2, we have a -5, we have a 6. Next up, variables in alphabetical order. We have a y cubed, y cubed, y cubed. We also had z and we had z. Simplifying this out, 2 5s are 10, 2 5s are 10, 10 6s are 60. 2 of them were negative, so we get a positive, so we just get 60. Next we have y's and we have z's. We had a grand total of 9 y's and we had a grand total of 2 z's. So our simplified form here is 60 y to the power of 9 z squared. Alrighty, if you're up for it, let's do some extension. Let's have a look at something a bit odd. The 0 exponent. Anything raised to the power of 0 is equal to 1, but anything cannot be 0. So let's suppose we have y, and we raise it to the power of 0. Then by definition of this rule over here, anything raised to the power of 0 has to be 1. In addition to this, suppose we look at something a bit more complicated. Suppose we have, let's say, 3z to the power of 0. Then by that extension as well, we're going to have 3 in brackets z to the power of 0, which in turn is going to turn into 3. Because remember, anything raised to the power of 0 becomes 1, provided anything is not 0, so we're not allowed to do 0 to the power of 0. Okay, let's have a look at how we can use this over here to simplify these guys over here. Suppose we have 2x to the 0 plus 1. Remember, anything to the power of 0 is just 1. So we're going to get 2 in brackets 0, or 2 in brackets x to the power of 0 plus 1. And then that 2x to the power of 0 is just going to become 1. 2 by 1 is just 2. 2 plus 1 is 3. So something that looks like we can't do anything about, so the 2x to the 0, is actually just something simple, 3. Alright, let's look at something a bit more complicated. 3x squared y cubed, in brackets 2x to the negative 2, y to the negative 1. Let's see how we can simplify this. We're going to start off by getting our coefficients and moving them to the left, 3 and 2. Then, we don't have to use the times symbol, sorry. Then we can just list our variables. We have x squared, we have x to the negative 2, we have y cubed, we have y to the negative 1. Alright, let's simplify further. 3 2s are 6, and then we're going to have x's and we're going to have y's. Now this is odd because we have negative exponents here. Now remember, negative exponent just means that we are borrowing the number here. So if we have 2 lots of x here, but then we have a debt of 2 x's here, suppose we have 2 oranges and then 2 get taken away, we have a total of 0 oranges. So what we can do is we're allowed to start summing the exponents. Same with the 3. 3 plus negative 1. Okay, the simplification of this is we have x to the power of 0, we have y to the power of 2. So this is going to become 6y. So the takeaway here is that when we have negative exponents, we just count backwards or we take away from what we originally have here.